Hello and welcome to this briefing session on the Bachelor's of Engineering with Honours in Mechanical Design and Manufacturing Engineering program, or in short, MDME. So today I'll be presenting to you some details about this program so that you will consider for your application into this degree. So as a start, let me just quickly introduce this program. This program started as a joint degree with Newcastle University with SIT in 2017, and hence we are about more than 3 years old, right, running into this program. So this program, as I mentioned, is a joint degree, so it is a partnership with Newcastle University. So the curriculum is actually jointly developed between SIT and Newcastle University. So this is also in respect to the delivery, and you will meet faculty, lecturers in both universities. So what this means that when you graduate in this program, you will be having a degree scroll, or you'll be awarded a degree scroll that has both the two university logos on your degree scroll. Okay. Without further ado, let me just go ahead to give you a little bit of background about this degree program. So this slide shows you the manufacturing in Singapore, right? The statistics shown here are from the latest in the manufacturing sector, where you can see that there is a 20% or around 20.9% of our country's GDP in the manufacturing sector. So this is a very substantial portion of the GDP of the country, and that's because it includes many key industry sectors, including precision engineering, transport engineering, electronics, chemicals, so on and so forth, as listed on the slide. So therefore, there is a large demand of engineers in this area. Hence, we developed this degree program so that we have graduates who can actually contribute to this industry area once they have completed the program. Here are the program objectives listed down in 3 main points. So the first point is really on the development of the degree program in terms of its curriculum. So what we are trying to do is to have foundational knowledge in mechanical engineering, and then this is supplemented with more recent advances and technologies in the areas of mechatronics as well as manufacturing. And then in the degree program, students will be trained and educated to be industry ready, all right, with skills in the theory aspects, as well as to know how to put these theories into practice so that they can actually contribute to enhancing processes in the manufacturing as well as the production environment. And lastly, the third point or the third objective of this program is really to look at the outcomes or the outputs of the program, which in general here is to support the manpower demands of the local industries in manufacturing so that our graduates are able to contribute in the areas of design, automation, and productivity. Here are the key features regarding the program. So there are actually 3 pillars of engineering knowledge considered in this program. As mentioned before, the base or the foundation is in mechanical engineering, and then we are also supported in terms of the 2 other main branches of engineering, which are in mechatronics as well as manufacturing. So I'll go into more details regarding the modules that are actually being taught within each of these pillars of engineering knowledge later. We consider a holistic education in our degree program, all right, whereby students not only learn about the theory and applications of the, for example, like machines on factory shop floor, but also be educated with the entire understanding of the manufacturing ecosystem. So this will include things at the processes at the middle management, including learning about manufacturing execution systems, MES, as well as all the way up to the corporate level at top management, which includes the logistics and supply chain, and also some awareness about enterprise resource planning or ERP. And of course, being a practical degree program, we also want to inculcate into our students very important industrial skills. This will include areas of lean manufacturing and Six Sigma, which is also encompasses statistical process control in terms of optimizing productivity as well as reducing lead times in production processes. And of course, SIT's key flagship program, which is the Integrated Work Study Program, or IWSP. So this is also incorporated into the degree program as part of your studies. So this is actually full-time work in the industry for around 6 months, and our students actually embark on work areas that are related to both productivity as well as design, right, in the industry. We are expecting around 90 to around 100 students, right, for this annual admission, and we welcome applicants from diploma holders or from other pre-university programs like A-levels or IB. And there are large or wide variety of job prospects for our graduates. So as listed there, of course, you can be an engineer, but in being an engineering role, it could be in many different types of job scopes, including research and development, R&D, manufacturing itself, mechatronics, quality project, mechanical design project, so on and so forth. And this program is actually housed in one of our satellite campuses at Nanyang Polytechnic. So our students actually undertake the program entirely in this campus premises, and all our lab facilities and resources can also be found at this campus. So here are just a little bit of emphasis about the 3 pillars of engineering knowledge in this degree program. So we want to have a base, all right, to educate our students in the engineering knowledge area as well as professional skills in demand in the industry. So we look at these 3 pillars. For the mechanical engineering pillar, we want our students to focus on mechanical design, particularly on product design. So you understand the design processes, right, from start to finish, and that it will be the emphasis there. And the next pillar is on mechatronics. And for mechatronics, we want to have some focus on industrial automation. This allows our students to improve things like productivity processes within a production line, and also incorporate things like robotics or automation to improve these processes. And finally, the third pillar is in manufacturing, and we want to focus on to educate our students in manufacturing management, so you actually know or are aware of all the different layers of systems within the manufacturing ecosystem, so that you are not only contributing on the factory shop floor level, but also middle management all the way to the corporate level. And finally, with all these 3 pillars together, all right, we hope that we can actually have student graduates who are actually practice-oriented at the end, be industry-ready, and also to be professional engineers. So now looking forward towards the type of modules that you expect to encounter during your studies within these 3 pillars of engineering knowledge. These are all listed on this slide. So starting off with the mechanical engineering pillar, you see that you need some fundamentals in mathematics and statics. Statics are things that are not moving. Dynamics are things that are moving. And then also learn about materials, how to do selection for materials for design purposes, understand the behavior of these materials through mechanics, and how to actually apply different machine elements to do design, things like gears, bearings, pulleys, belts. And also a very important element in mechanical engineering is also thermofluids. So under thermofluids, you learn things like heat transfer, thermodynamics, and also the behavior of fluids in terms of its dynamics, and how to do modeling and simulation so that you can actually understand the processes involved through simulation rather than building an entire system, which is more costly. And finally, also to understand the differences and also the relationships among materials and processes, particularly focusing for the requirements there in manufacturing. Then the next pillar is in mechatronics. So we start off with some basics in programming and also understanding of circuit theory and also electronics, especially digital electronics, which are becoming more and more important today in the industry. and how to do control of this dynamic system. So you'll learn to use software like MATLAB to be able to apply control theory, use transfer functions to determine the relationship between outputs and inputs, and then look at how to implement all this through systems for mechatronics, electromechanical systems, and also real-time embedded systems. And finally, towards the end or the final year of the program, there will be emphasis on areas of robotics and industrial automation, again, particularly to focus on the improvement of production processes on the factory shop floor. And then finally, the third engineering pillar is in manufacturing. So we start off in the first year for students to learn about how to actually design for manufacture. So you need to learn how to use some software skills to do computer-aided design, and also for the purpose of assembly and manufacturing processes. And we look into design and prototyping practices. So in this case, you'll be able to learn additive manufacturing processes using 3D printing. You'll also be involved in building different applications using systems like Arduino kits. So you can build simple applications that actually can function, and you can observe how they behave based on your design that you have done. And of course, the very important lean manufacturing and Six Sigma principles are also taught within the degree program in the second year. And this allows you to learn about how to optimize design processes and also production processes, and also how to actually minimize things like waste and have continuous improvement in production. And in the final year, you will also be able to learn about or be exposed to manufacturing systems management. And again, this is to do with getting the awareness about the entire manufacturing ecosystem. So you will learn the different layers of the manufacturing ecosystem, including the MES, which I've mentioned before. You also get to have hands-on experience with our learning factory that shows you how digitalization can be incorporated into the production process to improve the lead time. And at the bottom here, we also have to consider some professional engineering skills, which are also part and parcel of being an engineer. All right, you have to learn about things like economics and how to be involved or be actively involved in project management. And some important knowledge areas include finance, law, and standards for engineers, things like safety standards, how to consider risks, how to and be aware about the policies involved in, for example, like intellectual property, right? So all these are part and parcel of design, product design. And on the soft skills side, students will be undertake modules in technical writing and communication, right? This is to ensure that you not only have good ideas, but also able to convey these ideas in writing and as well as in presentation. And finally, one of our important professional skill module is in career and professional development, or CPD. This is to prepare our students, all right, to embark on our integrated work study program, or IWSP. So this includes training for resume writing and also how to perform during interviews. What you see here is typically the program schedule, all right, for MDME. So we are laid out in 3 years of the degree program through 3 trimesters. So the first trimester starts in September for 4 months, and then this continues on to the second trimester from January to April, and then finally the third trimester from May to August. So you can see that for the first year, students learn about fundamental principles. In the second year, we have the core modules, and below the core modules in the third trimester of the second year, you have OIP, which is the Overseas Immersion Program. I'll talk more about that in a subsequent slide. And that is immediately followed by the IWSP for about 6 months in total. And then after IWSP in the third year, students will specialize into the areas of manufacturing. So let's just have a look at the first program, which is the OIP, or Overseas Immersion Program, which occurred annually around the time in July. So the Overseas Immersion Program is a feature that is welcomed by a lot of students because it gives the students an opportunity to travel overseas to the Newcastle University home campus in the UK. So this will be for about 3 weeks in July, all right? And students actually get to learn new knowledge depending on what are available at the campus there, especially in terms of areas like research skills, health and safety, in engineering, how to actually look for resources in the library in a professional manner. And of course, being in the UK, you get to also visit some of the factories there. For example, in the past, the seniors have actually gone to the Caterpillar factory, all right, to learn about lean manufacturing principles and observe how these principles are being adopted on an actual production line. Also, students in the past have gone to another factory which is to do with heavy industries for Komatsu heavy engineering factory. So that's where they produce components for things like cranes and also tractors, for example. And you get to meet the Newcastle University community, right? You need to meet the staff there, you get to meet your counterpart students there. And at the same time, you have the opportunity to also experience British and Western culture. So there are just two pictures here from past OIPs, all right? And you can see student groups, group photos at the landmark locations in Newcastle. So the top picture is the St. James Park, the very famous stadium, football stadium for Newcastle United. And at the bottom there is the Gateshead Millennium Bridge, which is a very famous landmark upon the River Tyne. So back to the program schedule, we now want to have a look at the IWSP program, which spans across 6 months from the end of the second year to the middle of the third year of the program. So the IWSP, as mentioned before, is a 6 months work attachment in a relevant engineering and manufacturing company, mainly in Singapore, but of course we also have opportunities for students to also travel overseas, whether regionally or internationally. And this is also has to do with something that is related to the degree program that you are studying. And it contributes to 20 credits of the program. So this is quite substantial. So the entire program has 180 credits, and 20 credits is a substantial portion of the distribution of these credits. So students will be working again on design and productivity projects, be part of the day-to-day schedule or job scope in the company or in the industry they are attached to. And this is really to give opportunities for students to actually practice the knowledge that they have gained over the past 2 years of study in the degree program. And of course, there will be networking opportunities with important people in the industry. You get to learn from them, and hence this actually improve your professional skills in terms of also communication and how to actually practice professionally. This is a highly regulated program, all right, whereby you are actually being supervised by 2 supervisors. One is the academic supervisor, which is who is a faculty at the university, and also another supervisor from the company known as the company or work supervisor. So therefore, there is regular reporting requirements for our students when they are attached to the company. So students will need to submit things like bi-weekly logs, reports, and then also they have to return to campus to share their experiences with their peers and embark on some value-added programs like data analytics and also digitalization for manufacturing or for smart operations. So all these are included into this program so that students become well-rounded. They get the experience working in the company as well as able to enhance and enrich their knowledge areas in the mechanical engineering or manufacturing engineering. These are the program facilities available for our students to use and learn, all right? So they are very important to actually understand some of these engineering principles being taught in the degree program. And what you can see here from the list is firstly a thermofluids lab. So a thermofluids lab is where you get to learn about mainly fluid dynamics. We have electro-pneumatic and electro-hydraulic systems. So hydraulics and pneumatics are actually fluids that are actually being used that in the machining processes within a manufacturing line. So hence you get to understand the basic running forces behind these principles and get to optimize the components involved for these machines. Then we have the electronics lab. This is for students to actually learn how to actually build very simple applications based on electrical circuit theory and also understanding of electronic principles and components like microprocessors. Then we have an industrial robotics lab, all right? And in this industrial robotics lab, as you have seen in the pictures or photographs, there are different work cells for students to actually practice their control theory, how to do programming for robotic arms to do different kinds of applications like pick and place objects. And in the list there, you also notice two very important terms, AGVs and cobots. So AGV stands for automated guided vehicles. These equipment or instruments are becoming increasingly popular in the manufacturing line because they are used to transport goods, raw materials within a production line automatically. So these are mobile robots, and you can see a picture there showing an example of a mobile robot. So students get to learn how to actually do control and also design for applying these AGVs. And cobot stands for collaborative robots. So collaborative robots, something also is another technology that is gaining increasing popularity in the industry because it incorporates using robotic systems together with human operators. Because typically when you have a robot in a factory setting, you have to cordon the area, you have barriers to actually ensure that there is safety within the operation of the robot. But in this case, for a cobot, a collaborative robot, workers or operators get to work side by side with these instruments because they are designed to be safe to operate in this manner. So you get exposure to actually learn how these latest technologies or instruments through this program as well. And of course, like any typical mechanical engineering program, we have a workshop. So these are facilities that allow our students to do prototyping. All right, we have machining tools like grinders, drill machines, right, polishers, cutting machines. So this is to build very simple prototypes for project work. And of course, we also have a facility, a room dedicated to additive manufacturing. Particularly, we have many units of these 3D printers for rapid prototyping using polymers. And lastly, in the list, we have also an advanced manufacturing laboratory. This features one of our showcase equipment, which is the learning factory. This is shown in the bottom right photograph in the slide. And this is a modular system whereby students can connect various modules in different arrangement to produce an effective production line. And at the same time, students also get to learn digitalization principles, whereby it's not just about manual control of this equipment, but also to able to do control or things like predictive maintenance using digitalization principles through the cloud or through the internet. These photographs are just examples of how our students, together with faculty, are involved in the degree program. You can see photographs that our students are working in the lab, building prototypes, and also our lecturers and faculty supervising our students. And you will see that our students are actually having an enriching experience here in the degree program. They get to learn all kinds of engineering and important engineering principles From top left-hand side, you see our faculty teaching our students how to do additive manufacturing using a 3D printer shown in the photograph. And then on the top right, our students actually making the prototype from those components made using the 3D printers. And the bottom left, you have our faculty supervising our students on how to use different machine elements, in this case, to build a power screw, and also learn about motor design as shown in the photograph there. And the bottom right is just to demonstrate how our students work on these electro-pneumatic systems, how to optimize the components there to ensure that the fluid dynamics can be applied in a very efficient manner. So that is all I have to share about this degree program. Thank you for your attention, and I hope to consider your application into this degree. Thank you.